So now in this video we're going to expand on what I covered in the last video. So in the last video I took a 1 kilo ohm resistor, and you can see we have 6.1 volts across it, and the power supply voltage is 8 volts. So about 2 volts is being lost across the LED. Around that, it's going to change a little bit as we increase current, but in case, we have 6.1 volts across the resistor. So now if I open the circuit, so the short lead, the LED, the cathode is connected to the negative rail, the long lead, the anode, connected to the resistor, which comes to the positive rail. So anode more positive than cathode, lets the LED conduct if you have at least 1.6 volts, and the LED lights up. So now we're going to put the long lead down here and just take that current measurement again. And so we just looked at the voltage, and since it's a 1 kilo ohm 1000 ohm resistor, we know that 6.1 volts will have 6.1 milliamps right there. Pretty much spot on. So now this resistor is half the resistance. So for each volt across a 1 kilo ohm resistor, we have 1 milliamp of current. So you got 1 volt divided by 1000 ohms of resistance. That gives you the current. So 1/1000th of an amp, 1 milliamp. 6 volts divided by 1000 is 6 milliamps. So pretty straightforward. This LED has a 510 ohm resistor, and so what we're going to do is put another resistor parallel. So this is 1 kilo ohm right here, and pay attention to the brightness of the LED. Let's see if it gets brighter. Okay, you can tell a little bit that it's getting brighter. So LEDs don't change their brightness a whole ton, so twice the current doesn't really translate to twice the brightness, but they do get brighter. So in any case, now we have the two resistors. They're both 1 kilo ohm resistors, and so the voltages stay the same. We have the voltage across both of them, but now, oops, I measured current. That was very bad. It smells like something's burning. I think we burnt out this LED. Yep. Alright, so I replaced the LED. I'll also tip them to the side. You can notice their brightness change a lot more that way. I think I'll pop out one of the 1 kilo ohm resistors, and you can see it got more dim. So in any case, I fried an LED. Hopefully it worked really nicely as a fuse and protected the fuse inside this meter. It should have a fuse. Anyways, so in any case, now we have the two resistors, and let's take that voltage reading across the two resistors. So since they are in parallel, they have the same voltage across them, 6.1 volts. And so now they're both passing current. They both have a voltage across them, the same voltage, so they're both passing current. We have twice the current. It's as if we have half the resistance. So let's look. Now we will take that current reading, and we should have the same amount of current going through this single resistor right here. And yeah, there we go. So there you can see we have 12 milliamps of current, and let's turn this one around, and again we should have 12 milliamps of current because it is a 510 ohm resistor. So a tad bit less because it's 510 instead of 500 ohms of resistance. But in any case, we made the math easy to get twice the current through an LED. So the rest of the circuit has to be the same, but the current limiting resistor, if you want twice the current that you're getting with a particular current limiting resistor, you can either put the same value in parallel to get half the resistance, or just use a single resistor that is half the resistance. One advantage right now of two of them in parallel, they're passing less current, each one of them, than this single one here. So they are sharing the amount of current. They're not getting as hot, and so that's one reason. If you're getting too close to the wattage rating of a single resistor, you can just use a couple higher value resistors in parallel. and they will both dissipate a lower amount of heat than a single one. So now let's take this one step further. As we said, so a 1 kilo ohm resistor, 1000 ohm, makes the math really easy. For each volt across the resistor, you get 1 milliamp of current. So cutting that resistance in half, this is a 510 ohm resistor, so okay, I guess it's just written up there, 510 ohm, we'll get twice the current, which we can't really see terribly easily, but the meter definitely made clear. So now we're going to go to a third. So I do have 330 ohm resistor, and so first let us add a third resistor in parallel, because we could do it this way too, but normally you wouldn't do this way. It's not going to get, the brightness isn't going to change as much because we're going from, okay, it's not, probably can't even tell. So any case, we have that there, and we will pluck the single resistor. It is pretty warm, and add the 330 ohm resistor. So now we're really close to the 20 milliamps that these LEDs are rated for. And if I point it towards you, it is quite bright, but I will tip them to the side to try to make them a little easier to see on camera, and that they're not just a glowing ball of fire. But in any case, let us look. The voltage stayed the same at the resistor now, so 6 volts works just fine for this. So we got a little less than 6. The LEDs are blocking a little more voltage, so there's going to be a little less voltage across the resistors. And by the way, when I ended that last scene, I made sure to put the meter to voltage instead of leaving it at milliamps, so that I won't fry an LED again right at the beginning of this scene. So I'm going to turn these around, but again, this is pretty straightforward. In both cases here, we have 1/3 the resistance, and so we're going to have 3 times the current. So you don't have to use a lot of formulas and stuff in electronics. A lot of it is just mental math. So you start with knowing a 1 kilo ohm resistor at 1 volt is going to give you 1 milliamps. So let's say you want 5 times that current or something. You need 1/5 of the resistance. And so you would use like what is that, 200 ohms of resistance. That would have to be lower voltages than what we're dealing here. But you know, it's really simple mental math like that. And so in any case, hopefully this helped you. This comes a lot while you're designing your own circuits, and you just kind of get a feel, in this case, for how much voltage and what resistance you're going to need for a particular LED. And so you start with whatever voltage you know you're going to deal with, and then everything but 2 volts, but if you're just powering an LED, is going to be across the resistor. So you're going to have 2 volts less than the power supply voltage, approximately. And then you just work from there. You already know 1 volt across 1 kilo ohm of resistance is 1 milliamp. And so either the voltage already works for you, or you make a adjustment with the resistor. Half of the resistance if you need twice as much current as you're going to get with a 1 kilo ohm resistor. So pretty straightforward. So hopefully that helped you when you're trying to pick what resistor you're using in the future. Also, the meter is at milliamps. I either want it at voltage or off, because both of those are safe. And I shouldn't leave it at milliamp when I'm done measuring milliamps. And luckily, the fuse in this case was the LED that we fried. In fact, let's zoom in. It is charred really bad. So there it is. You can clearly see the burn mark there at the anode, and it looks like it's only at the anode there, but definitely there. It looks like the top is kind of burnt too, because this one, the top's not as dark. So yep, we fried her.